Hello everyone. Hey, I hope you all are doing well. Welcome to Ask IITians. So today we would be talking about linear equations in one variables. As you all can see the screen, we will be talking about linear equations in one variable from class 8 chapter, right? So these are the things which we would be covering in today's class. This chapter is very much important from your final examination perspective, and it also has various real life applications. So the topic which we are going to cover today in today's class is how to solve these equations which have linear expressions on one side and numbers on the other side. Okay. And we would also be talking about their applications, that is applications of uh, linear equations. Okay. So let's see, let's try to understand. And this is like, uh, let's say we have, first of all, we would say, let's say we have an equation, that is 2x minus 3 equal to 7, where the linear expression is on the left hand side. That is, you all can see the screen that 2x minus 3, if you just look at 2x minus 3, this is an expression. Now if you are equating it to a constant, it becomes an equation, right? So the step one to solve this is, transpose all the constant term from the left hand side to the right hand side, right? From the left hand side to the right hand side. So here we will have the constant minus 3 on the left hand side, which will be transported to the right hand side, right? Then the equation will become 2x is equal to 10, right? Now step 2 is divide both the sides of an equation by the coefficient of the variable. Now first of all, we need to understand what is a variable, right? So the algebraic letter, the English letters which are denoted like maybe A B C X Y Z P Q R L M N, these are like your variables. What do you mean by variables? Their values keep on changing. The values of the variables keep on changing from time to time. That is, when you change the value of variable, the entire equation changes, right? Because this equation will be true for a particular value of variable only. And when we say you have to solve the equation, it simply means you have to find the value of that variable for which the equation holds true, right? For which the equation holds true. Now, the step 2 is divide both sides of the equation by the coefficient of the variable. So in the above equation, 2x is on the left hand side, which means the coefficient of x is 2 here. The coefficient of x is 2. On dividing the equation by 2, we get, so 2x divided by 2 is equal to 10 divided by 2. So from here we would say x is nothing but 10 divided by 2, which is just 5, which means the equation 2x minus 3 equal to 7 is true if and only if, I double f, if and only if x is equal to 5. If and only if x is equal to 5, right? So next, this is the like the flow chart of 7. And then when you divide, so first you have to transport and then you have to divide, right? This is how we basically learn how to solve linear equations in one variable, linear equations in one variable, right? So let's now see a question based on this, right? It says sum of two numbers is 74. So you would say, let the numbers be, let the numbers be x and y, right? One of the numbers is more, is 10 more than the other. It says so here it says sum of numbers, so you can clearly say that x plus y is equal to 74. One of the numbers is 10 more than the other. So one of the numbers is 10 more than the other, which means the other number y is 10 more than the other. So you can say x plus 10 is equal to y. Basically y is 10 less than the x. So here it says what are the numbers, so you have to determine what are the number. So you would simply say, let if these are your equations too, linear equations, you can just substitute this value of y. So you will say substituting value of y in equation 2 in the above equation 1, right? The value of y which is in equation 2, in the, you have to substitute that value in equation 1. So you would say we get x plus 10 is equal to 74, which implies 2x is equal to 74 minus 10 is just 68. So we have transported this 74 minus 10 is 64. From here now you would say divide the coefficient here is 2. So you would say when you divide it, you get x is equal to 32, right? X is equal to 32. So one of the numbers is 32, the other number you have to find out. So you would say y is equal to 32 plus 10, which is 42, right? Y is equal to 32 plus 10, which is 42, right? So I hope these, the numbers are what, 32 and 42, because 32 and 42 they also add up to 74, right? So one of the numbers is 32 and the other number is 42. I hope you all understood how this works, and how is the uh, how to solve basically a linear equation in one variable, right? So now let's quickly talk about its application. So what would be the applications of linear equations in one variable or two variable basically? So you would say like the previous question which we saw was purely theoretical because it was involving sum of two numbers and all of that. But when we talk about maybe let's say mm, there are two people, there are two persons, one is Ramesh and one is Suresh, right? There are two persons, Ramesh and Suresh. Okay, let's say these two are brothers. So Suresh is 10 years older than Ramesh, right? Suresh is 10 years older than Ramesh. So in that case, we would say that if Suresh is 10 years older than Ramesh, so we would also be interested in knowing that how is the age of Ramesh and Suresh related, and how we are going to uh, represent and find their exact ages, right? So if we know some additional information, that is, let's say if the difference between their ages, if the difference between their ages is, so we can clearly say that the difference between their ages is 10 here, right? Because Suresh is 10 years older than Ramesh, so Suresh's age minus Ramesh's age is just 10 years, right? Now if you know some other information, that is, let's say 2 years hence. What do you mean by 2 years hence? 2 years hence means after 2 years, let's say Suresh's age will be double that of Ramesh's age, right? Will be double that of Ramesh's age. So now this will give you a new equation. This will give you a different equation altogether. So now when you have two equations, you will be able to get the exact present ages of Ramesh and Suresh, right? So that is why these linear equations are studied. And so you would say let the present age of Ramesh be x years, let the present age of Suresh be y years, and so on, right? So you would be able to get the equations, right? So the first equation would be y minus x is 10, and the second equation would be 2 years hence. So 2 years hence means our Suresh's age would be y plus 2, and Ramesh's age would be x plus 2. So Suresh's age would be 2 times double x minus 2, or rather x plus 2 again, because Ramesh will also be x plus 2 years. So this is how you would be able to get, right? So when you solve these two equations, you would get the age of Ramesh and Suresh. So these are application based. Now how will you solve if you don't know how to solve linear equations, right? So this is how we solve linear equations, and these are some of the basic applications of linear equations. So now again, let's try to read it. So what do we say? In real life, applications are vast. We have discussed it, right? They are vast applications. Now, to tackle, what do? We need to first translate the problem statement into a mathematical statement, right? Like if you see in the previous question, what did we say? The problem statement was Suresh is 10 years older than Ramesh. So we said difference of their ages is 10 years, which means y minus x is 10 years. So identify the unknowns. What are the unknowns? The percentage of Ramesh and percentage of Suresh. So we assign them variables as x and y. They were the unknowns, they were supposed to be found out, right? Is the information obtained sequentially. So sequentially means we have the information, that is Suresh age minus Ramesh age, and the other information as after 2 years Suresh age would be double that of Ramesh age. So in that case we would be saying uh, like how to write them algebraically or mathematically. Then we have frame an equation with the help of an algebraic expression and the data provided. So we also got the equations. So now retrace your solution to the problem statement and analyze if it suits the criteria of the problem, right? So here in this case, if you would have got the age as negative, you would have said that okay, no, this is not even possible, because you can't get the age as negative, right? Because how can an age of a person be negative? So in that case, you would be able to check the authenticity of the problem, like does this problem even have some meaning, or does this even are the numbers correct, is there a printing error or something like that? So these are the authenticity check, or the suits the criteria on an analysis of this, right? Let's now solve one more question, right? So here it says Rishi and Vani. There are two people, Rishi and Vani. Rishi is twice as old as Vani. So you would say Rishi's age is twice that of Vani's age, right? This is the current scenario. 10 years ago, this is the present age, right? These are the present condition. Okay, now he's talking about 10 years ago. 10 years ago, so we would say first of all we are talking about find their present ages. Now, so you would say let the present age of Rishi be X, and let the present age of Vani be Y years. Okay, X years and Y years. So now we would say Rishi is twice as old as Vani, na? So Rishi will be X is equal to 2 times Y, twice as old as Vani, right? So which means if Vani is 3 years, Rishi would be 6 years. Now it says 10 years ago, before 10 years, his age was thrice as of Vani. Okay, so 10 years ago means Rishi's age 10 years ago would be X minus 10, and Vani's age 10 years ago would be Y minus 10, right? So 10 years ago, Rishi was thrice as old as Vani. So you would say, now let's solve. So substituting x is equal to 2y in this equation. So 2y minus 10 is equal to 3y minus 30. We have just used a distributive law here, right? 3 into y minus 3 into 10. So 3y minus 2y gives us y, and minus 30 gives us plus 30. 30 minus 10 is 20. So which means Vani's age is 20 years, right? And Rishi's age would be 40 years in that case, right? Rishi's age, because he's twice as old as Vani now, na? So that would be 40 years. Now you can also check the authenticity by saying that Vani's age 10 years before was 10 years. Rishi's age 10 years before was 30 years. So 30 is 3 times 10, right? This is how it is. So that was correct. The problem statement was correct, and that is why it also correct, right? So therefore it is implies Vani is 20 years old and Rishi is 40 years old. So again let us retrace our solution. So it says if the present age of Vani is 20 years, then 10 years ago her age would have been 10 years. Rishi's age would have been 30 years, which satisfies our problem statement. Right? These real life problems are being solved just if we know the solution, just if we know to solve the linear equations. So we did not do any rocket science, we just substituted the value of one variable in the other equation and we got the values, right? So this is how linear equations works. So now I'm giving you all some practice questions to solve as a part of assignment homework. So I hope you all will solve these questions and learn from it. So you have to solve x plus 1 upon 2x plus 3 equal to 3 by 8. And the other one is larger integer. What do you mean by integer? Do they include decimal points? You will say no, integers are do not include decimal points, but they include negative natural numbers, right? So negative numbers which are on the other side and on the number line, right? So here you are given a problem on the word problem on the basis of integers. So this is how it works, and basically it's amazing to understand this. So I hope you all have enjoyed this session and had a glimpse of what it linear equation and their variables are. All right, till then just take care, stay safe during this pandemic, and I hope you will be you are enjoying learning with Ask IITians. So till then, take care and see you all in next class. Bye bye.